Google DeepMind's next chapter. Demis Hassabis has described himself as standing in the foothills of the singularity, and now he wants to spend his time at the summit rather than in the base camp operations center. Google announced that Hassabis is stepping back from day-to-day operational leadership of Google DeepMind to become chair of GDM and chief scientist of Alphabet, a move he and Sundar Pichai frame as freeing him to actively shape the future of AGI. Koray Kavukcuoglu, GDM's CTO and chief AI architect since the early DeepMind days, steps up as SVP of Google DeepMind and takes over Gemini model development, frontier research, and the Gemini app and developer teams. The bigger surprise is Jeff Dean's departure after 27 years at Google. Dean and senior fellow Sanjay Ghemawat are launching an independent public benefit corporation to accelerate discoveries in ML, science, and engineering. Google is backing it as a founding investor and cloud partner. The pair built the infrastructure scaffolding, MapReduce, Bigtable, TensorFlow, that the modern AI era runs on. Their exit as a unit to start something mission-driven rather than retiring quietly signals they believe something more important can be built outside Google's orbit, not inside it. The operational read is straightforward. Pichai is consolidating direct reports. Kavukcuoglu now reports directly to him, shortening the chain between product decisions and AI research. Hassabis' pivot to isomorphic labs, where he wants AI to help finally cure diseases like cancer, suggests the best-case scenario for DeepMind's founder. The models are good enough that daily management is less interesting than applying them. The risk is more subtle. DeepMind's culture was built around Hassabis' personal credibility with researchers. Chair titles have a way of becoming ceremonial. Whether Kavukcuoglu can maintain that gravitational pull while simultaneously shipping Gemini 4 and managing 950 million monthly Gemini app users will determine whether this is a succession or a slow unwinding. Data exfiltration, privacy leaks, and the LLM Trust Deficit. The Grok CLI data exfiltration story broke in July, and now someone has built the forensic tool you actually need afterward. GrokPatrol is a single static Go binary. Zero dependencies, no network calls proven at the linker level by asserting that net/HTTP and C or YPTO/TLS are absent from the dependency tree. Read only every file open is ORDONLY. That answers the question, what did the Grok CLI take from this machine, and which secrets went with it? It scans Grok's logs including rotated and gypped, the upload queue at .grok/upload queue/staged archive manifests, naming the Gs://Grok code session traces destination bucket, and critically, enumerates secrets in the uploaded object set by diffing get rev list.objects hit against the working tree. The secrets it flags first are the ones you cannot see in your checkout anymore. The deleted.nv, the rotated.pem, because those are the credentials that went out in Git history and are hardest to remember to rotate. The design constraints are worth noting. GrokPatrol never executes the Grok binary. Not even for .version, because the Grok CLI carries a collector that runs outside its own permission system. Launching it to ask a question could start a session. A degraded scan macOS TCC blocked a directory never reports clean. It reports indeterminate and prints what it could not see. Version detection covers 0.1. 212 through the latest observed, with 0. 2.93 confirmed affected and the collector reportedly present through at least 0. 2.99. This is what incident response tooling should look like. Every finding cites something you can go look at. Absence of evidence is explicitly not evidence of absence, and the tool itself is small enough to grep in an afternoon. On a different attack surface entirely, researchers at MISC found 3 WebKit features: DNS prefetching, WebAuthn-related origin requests, and web transport that bypass proxy configurations on iOS and macOS, leaking the user's real IP address and DNS queries even when traffic is routed through a proxy. The DNS prefetch leak is triggered by a simple HTML tag, works since iOS 26.0, and affects Apple's iCloud private relay as well. WebAuthn's related origin requests and credential validation to the OS credential service, which fires an HTTPS fetch directly from the device, unaware of any proxy. Web transport opens a direct QUIC connection that WebKit never offers to the proxy session. All 3 affect every iOS browser since Apple requires WebKit, including iOS Tor browsers. VPNs are not affected because they tunnel at the system level. Meanwhile, Cloud.ru released Guardrails WOM Filter Xproc, an Envoy external processor that masks PII and secrets in LLM-bound traffic using roughly 260 built-in regex rules covering credentials, API keys, access tokens, IP addresses, and Russian-specific personal data SNILs, INN, OGRN with checksum validation. It replaces detected values with safe placeholders like on the way to the model and restores originals on the way back, including in streaming SSE responses and tool call arguments. The provider never sees sensitive values. The client never sees placeholders. Storage backends include in-memory, Redis, or Postgres with optional AES256 GCM encryption. Open weight models between benchmarks and reality. Liquid AI released LFM2.52.6b, a 2.69 billion parameter model with 128K context and tool calling, post-trained specifically for multi-step agent workflows. The Q4 KMGGUF is 1.67 GB and already works with llama.cpp. Vendor reported speeds: 30 TOC/s on a phone, 113 TOC/s on a Ryzen AI Max, plus 395, 220 TOC/s on an M5 Max, under 2.5 GB memory. Benchmarks are competitive for the size. Tool Sandbox 77.83 versus 76.44 for QWEN3.59b, IFBench 59.17 versus 56.47. But coding and knowledge-heavy work remain weaknesses, and Liquid's own model card says it is not recommended for agentic coding. Community testing on a Snapdragon 8 Gen 3 showed 20 TOC/s on a test prompt, falling to 16 TOC/s on a 2K token response, and one user's extended tool calling test produced a spectacular failure. The model hallucinated a date of March 2026, then snowballed through pages of web searches, all confirming that hallucinated timeframe, ultimately delivering a confidently wrong answer. Small models make sense as cheap worker agents doing extraction and repetitive tool calls, not as your smartest assistant. InclusionAI's Ling 3.0 flash weights landed on Hugging Face. MIT licensed, ungated, with BF16 at roughly 255 GB and an official FP8 at roughly 128 GB. The architecture is 1.275B total with 5.1B active per token, using 512 experts with 8 active, considerably finer grained than most MOE releases. Thinking mode is a per request toggle in the chat template rather than a separate SKU. The FP8 at 128 GB is the practical number. It fits a big unified memory box or a multi-GPU rig without community quanting. The open question is inference backend support. llama.cpp's handling of the Bailing hybrid architecture remains unclear, potentially limiting this to VLLM and SGLang for now. DeepSeek is raising prices, and the community response on local llama amounts to a collective shrug. The consensus. DeepSeek's first-party API was significantly cheaper than anyone else hosting DeepSeek v4, so the price increase likely brings it in line with third-party providers on OpenRouter. Roughly a 5x increase, but still very cheap in absolute terms. The real question for local-first users is whether this changes the break-even math on buying hardware. Several commenters noted they were already considering upgrades, and the open-weight nature of the models means there's a price ceiling. Anyone can host it if they find cheaper compute. The more substantive DeepSeek story is that v4-0731 still struggles with instruction following and system prompt adherence. One practitioner running it locally at full precision reports that no matter what they try. First person, second person, Chinese, English. The model ignores rules, prompts, and skills. The technical explanation is revealing. DeepSeek v4 stores rules and skills as compressed summaries, not raw text. Of 43 layers, 20 see the entire context squeezed into 128 token compressed entries, 21 see it at 4:1 compression, and only 2 are fully dense. The system prompt survives, but the exact wording does not. This is the same sparse attention compatibility cliff observed with v3.2. Running these models without native sparse attention support in the inference backend concretely degrades quality. The practical advice from experienced users: write firm positive instructions, list workflow steps and their order, avoid hedging language, and accept that DeepSeek models need to work in their style rather than conforming to harness conventions designed for Claude or GPT. Agent frameworks and the persistence problem. NVIDIA released OO Agents NoO, a model-agnostic Python framework that takes a different approach to agent development. Agents are Python objects. Methods with bodies become LLM-driven generation methods at runtime, type annotations serve as contracts, and docstrings serve as prompts. The model acts by writing Python in a Jupyter-style REPL with access to self, imports, and helpers, which means Python methods and type annotations supply the callable interfaces instead of separate tool schema definitions. The framework supports typed-i/o with auto-retry, live object arguments passed by reference, and model callable context and event APIs. It comes with an important safety caveat. The AST-level code validation and module deny lists are defense-in-depth guardrails, not a containment boundary. NVIDIA explicitly states that Open gives arbitrary file access. ImportLib can load modules from a path, and reflection reaches the rest. The containment boundary must be OS-level isolation like a container, VM, or NVIDIA's OpenShell. Kua, which has evolved from its original pitch as Docker for computer use agents to a cross-OS agent sandbox with benchmark-leading performance, now includes Kua drivers. Background computer use on macOS, Windows, and Linux that lets agents click, type, and verify without stealing the cursor or focus. The same CLI and MCP server works across all three operating systems from Claude Code, Cursor, Codex, and custom clients. The broader QA ecosystem includes agent-ready sandboxes, one API for any VM or container image, QA Bench for evaluating computer use agents on OS World and other benchmarks, and Loom for macOS virtualization on Apple Silicon. Google's Gemini Spark can now tap into Chrome's Auto Browse feature to handle complex online errands using the user's logged-in accounts. Scheduling apartment viewings, researching flights, starting booking processes. The permission model is explicit. Gemini tells you it can use your money before it does anything. Whether this runs in the user's actual Chrome session or a sandboxed browser appears to vary by region, with some users reporting sandboxed-only access. The more interesting design question comes from a discussion about Meta's Muse Code Beta, which can keep asynchronous subagents running across restarts, record work in an append-only local event log, and sustain 1000 plus tool calls for up to 24 hours. The thesis: decoding agents often fail not because they cannot write a function, but because they lose state, repeat work, or report success before the task is verified. Persistence attacks that bottleneck directly. The counterargument is equally sharp. A durable agent can also preserve a bad assumption for 12 hours, burn through tokens, and create coordination bugs harder to audit than a single model's mistake. As one practitioner put it, if it can't check its own work, run the tests, actually look at the diff, then all persistence does is make the wrong answer bigger. MCP provenance and source-aware verification. A research paper from Multiverse Computing introduces Provenance Guard, a source-aware verifier for answers produced by LLM agents using Model Context Protocol (MCP). The core insight is that existing factuality metrics evaluate whether an answer is supported by available context after evidence has been pooled. But they miss a critical failure mode the authors call cross-source conflation. A claim may be supported somewhere in the evidence while being attributed to the wrong source. Consider a medical agent that states, according to the patient's chart, empagliflozin reduced a mortality endpoint. The mortality claim might be supported by a clinical trial abstract, but not by the patient's chart. A source-blind verifier sees support in pooled evidence and passes it. Provenance Guard rejects it because the stated attribution is wrong. The system consumes captured MCP traces with stable tool IDs and source IDs, decomposes answers into atomic claims, routes claims to source-specific evidence using consigned similarity over source embeddings, checks support with NLI and an attention-derived token alignment proxy, and separately compares the claim-stated attribution with the routed source. On a held-out split of 40 traces and 361 claims from a medical domain corpus, Provenance Guard reaches block F1 of 0.802 and source accuracy of 0.858 over 260 source-eligible claims. Source-blind baselines on the same data. Minicheck 0.783, Ragus faithfulness 0.758, align score 0.662, summa CS 0.436. But none of them emit claim to source IDs. On a harder multi-source benchmark with many semantically close candidate sources, block F1 holds at 0.846, but source plus relation accuracy drops to 0.229, confirming that exact source ownership remains genuinely difficult when wrong sources are topically plausible. The paper is honest about this limitation. A conservative blocker can still fail to identify the exact supporting provenance object. On the practical MCP tooling side, a developer released QuillBDef MCP, an MIT-licensed MCP server and CLI for PDF operations. Merge, split, rotate, watermark, Bates numbering, metadata cleaning. That runs entirely on the local file system with no network calls. The motivation? Every PDF API wants you to upload the file, and if your agent handles contracts, discovery docs, or medical records, the upload is the problem. Built on PDFlib with STIAO transport only, small enough to audit in an afternoon. AWS open-sourced the Context Ontology Accelerator, a semantic context layer that combines knowledge graphs, formal ontologies with Hermite/ELK reasoning, and rule-based systems with AI agents. The architecture follows a scan model serve workflow. Connect data sources and discover schemas. Induce and manage ontologies with a unified semantic graph. Then serve context to agents via SPARQL, federation, and MCP tools. Access is governed by namespace isolation and role-based access control. It is published as a read-only mirror. Training, serving, and code-based intelligence. Prime Intellect has assembled a full-stack platform for training, deploying, and continuously improving custom models, anchored around reinforcement learning for agentic workflows. The platform includes the open-source verifiers library for creating RL environments, a CLI loop init, develop, eval, push for iterating on RL-trained agents, 2 500-plus community environments on their hub, managed training workflows, and dedicated or serverless inference with native LoRa support. Their case studies are specific. RAMP trained a small RL-trained subagent called FastAsk that beat frontier models on accuracy at spreadsheet search while running faster and cheaper, and Zapier uses their eval infrastructure as a continuous agent improvement loop. The Prime Agent harness, built around their recursive language model, reaches 95.5% on ARCAGI. 3. With Opus 5. Their Intellect 3 release, a 100B plus MOE trained with large-scale RL, 12B active per forward pass, MIT/Apache licensed, remains one of the most thoroughly open frontier model releases to date. Superlinked open-sourced its inference engine CLI, a Kubernetes native cluster designed to run the full stack of models behind agents. LLM, OCR, vision, embeddings, re-ranking, and content policy, all in one deployment. The differentiator is a cluster-wide queue that maximizes GPU utilization by letting worker pods pull from a shared queue rather than having each worker manage its own. SIU wraps whichever model server proves best for a given model. VLLM, SGLang, TensorR, TLLM, TI, and handles model profile hot reloads without restarts. It runs on AWS EKS, GCP GKE, or Azure AKS, and offers air-gapped installs for mirrored model snapshots. They also offer free inference grants for selected projects. Repowise bills itself as code-based intelligence for the AI era, an open-source AGPL3.0 tool that indexes a repository once and serves both AI agents via 10 MCP tools and a generated clade.md and humans, a verified wiki, defect-validated code health score, and architectural decision records. The headline benchmark, in a real agent loop with codecs on Django/Django n=43 PR0.0001. Repowise cut output tokens 31.6% and reached answers in 3.8 tool calls instead of 7.2. The code health score, 1/110 number from 21 deterministic signals, achieves ROC/AUC of 0.74 across 21 repos in 9 languages at predicting which files will have bugs, matching, or beating published academic models. The PR bot posts deterministic reviews with 0 LLM calls, so the same diff always produces the same analysis. Soup, the fine-tuning CLI that turns LLM training into a 3-command workflow, shipped v0.72.4 with preference learning losses DPO, ORPO, SIMPO, KTO now running over layer streaming. The clever bit. DPO needs a reference model to compare against, and a second copy would double memory, defeating the purpose. Soup uses the same streamed base with its adapters switched off. One set of weights, one stream. Measured on an RTX 3050, 4GB, stream DPO peaked at 0.914x, the supervised fine-tuning peak memory, forcing a real second model cost plus 730 MB. The honest trade-off, the reference is free in memory, not in time. DPO reads the layer stack 1.52x as often per step. GRPO and PPO are explicitly excluded because generation rereads every layer per token, which streaming cannot amortize. Creative AI and local hardware tinkering. Cadence 2.5 and Minimax H3 OpenWeight went head-to-head in a video generation comparison that has the local LeMay community cautiously optimistic about the state of AI filmmaking. The outputs look impressive enough to prompt one commenter to hope for AI-generated seasons of Firefly, though another captured the current aesthetic limitation well. It has taken Hollywood's worst quick-cut spectacle without essence to the maximum. The technical quality is advancing faster than the artistic control, but the R&D behind these models continues to push boundaries that may yield breakthroughs in other domains. On the audio side, Cert2Speech is an open-source tool for converting SRT subtitles to narrated speech with automatic duration matching, the genuinely hard problem that most TTS tools ignore. It uses pitch-corrected speed adjustment, automatic regeneration, pause modification between words, and exact placement of silence between subtitle cues. Multi-speaker support works via simple templating speaker name in the subtitle, and voice cloning is supported. Dependencies are minimal. Python, NumPy, Llama.c, P, and GGU speech models. Performance on an RTX 4080 laptop GPU runs 1213x real-time. CPU only manages 1.52x. While waiting for QWEN3.827B, one hobbyist repurposed a kid's old 32x32 pixel DeVoom display as a GPU cluster status monitor for 3 RTX A6000S running QWEN3.5122B on a VLLM Ray cluster. The build, including Ray dashboard API integration, VLLM metrics endpoint, and Vidiosmy calls over SSH, took GLM 5.2 about 20 minutes to build and another 5 minutes of human polish. The hardware set up 3 Dell Precision 7960 workstations, each with a 64 GB RTX A6000, plus a Dell Pro Max GB10 for Bluetooth and secondary inference, represents the kind of local-first infrastructure that has steadily drifted from hobbyist roots toward the $40 K workstation territory. But the pixel art dashboard is a reminder that the tinkering spirit persists even as the hardware floor rises.